Okay, so today we're going to do discrete probability distributions. And discrete probability distributions come from numbers that are countable. In other words, we can count from one number to the other. Now, they may be fractions, they may be decimals, but you can travel from one number to another number. Okay? First of all, our outcomes have to be numerical. And the reason why they have to be numerical is because we want to be able to do math with them. We want to be able to find the mean and the standard deviation for our outcomes. So let's consider a one coin flip. In a one coin flip, we know that we have outcomes of heads and tails. And we know that the probability of heads occurring is 0.5, and the probability of tails occurring is also 0.5. But what we want to do is we want to be able to express this numerically. So we change it a little bit to adjust for it, and we say, okay, we're going to let x, our random variable, be the number of heads. And now I can write my discrete probability distribution as a t-chart where I have x and then I have p of x, where x represents my numerical outcomes. I can either have 0 or 1. And then my probability that those occur are going to be 0.5 and 0.5. So this is one example of a discrete probability distribution. One thing to note is that the sum total of all of our probabilities has to be equal to 1. And that's by our law of probability. Also to know that any of our probabilities has to be between 0 and 1. We discussed this last time, okay? Now, we can find the mean and the standard deviation of these values. And the way that we find the mean is that we're going to do the sum of x times p of x in each successive row. Now I'll do a couple of examples with you on how to do this by hand, but then I'm also going to show you in StatCrunch how to be able to do it as well. So in our example, the mean is going to be equal to 0 times the corresponding probability of 0.5 plus 1 times the corresponding probability of 0.5. And that's going to be equal to 0.5. So what that means is that the average outcome that we get is half of a head, which sounds ridiculous. However, it's kind of what you would expect, is that the mean would be somewhere in between 0 and 1. And because there's a 50-50 shot between a head and a tail, it stands to reason that's right in the middle. Now, standard deviation's a little bit different. Standard deviation is the square root of the sum of x squared times p of x minus the mean squared. And that's all underneath our square root. So in our case, our standard deviation is going to be equal to 0 squared times the probability of 0.5 plus 1 squared times the probability of 0.5 minus the mean of 0.5 squared. So and I get 0.5.